Good. So for the homework, there's a few things. Number one, if you have vertical and horizontal asymptote, it has to be dashed line, and you label the line equation on the side of your asymptote. Number two, when you find the hole, you have to find the location, not just x equal to 0, there is a hole, but where is it on the y? To find the location, like last time, we will substitute that point, x equal to 0, into the simplified version, right? So 0, -3. So you need to find that location and put a hole on the graph, so an empty circle. When you find the xy intercept, you also need to label it. This one is actually wrong. Look at this. The hole and the y-intercept, they are the same. So which one is it? Does the hole exist? The hole means it's undefined, so we should cross out this one. There is no y-intercept in this case, right? So that's why we put the empty circle there. Is there a slant asymptote? Slant asymptote means after you divide the leading term, it becomes a linear equation, mx plus b. So the m behavior will become like a slant asymptote, like a line. If you divide and become a quadratic, your m behavior will behave like a quadratic when you zoom out from far, far away. If you divide, become a cube, then the m behavior will become the cube function behavior. That's the m behavior. Okay? So like for number 1, you see the top leading term is x cubed. The bottom is lower degree, right? 4x squared. When you divide, the top become higher. So what happened is when I try to divide the leading term, you got 1/4 x. What does that mean? This is the slant asymptote. That means the m behavior will follow this slope of 4, okay, at the end. Okay? We don't expect you to sketch this kind of graph, so we don't need to sketch it. So all the other graphing, we're gonna get into the detail on how to graph it, okay? So tonight, you're going to go back to fix your day 1 homework. I'm not happy with it. Can I just take a look? And then finish today's homework based on what I teach you today. Okay? So let's start from today's lesson. Yes?
Is the correction due like on next class start or like on like today?
Correction?
Yeah.
I want you to pay attention right now, and then when you do homework, you can make correction. I won't give you a score until next week. Is that your question?
Yeah.
Okay. Yes, so I want a perfect graph, all right, after today's lesson. So we now eat. What is this? Is this? Oh, we already did this, didn't we? Okay, sorry. Last time where were we? We did the horizontal asymptote, right?
It's like this.
This one we didn't do.
Yeah.
Okay, so let's review this. When you start with the graphing rational function, these are the steps. First, we can simplify, factor and find the simplified version and try to find the x and y intercept. All right, how to find it? The x-intercept are finding the zeros. That's when the numerator on top of the fraction, the numerator. How do you spell? Numerator, equal to 0, right? How do you find the y-intercept? Well, you will set x equal to 0 to find y. That's easy. Find any vertical asymptote or hole. This one, how do we do that? We need to factor the top and the bottom. After you factor, the factor that you can cancel the common factor, that will be your location of the hole. If after you cancel there is some factor in the denominator, that is where you find the vertical asymptote. It's the undefined point. Create this wall that no curve can cross, right? After all that, we want to find the end behavior. Is there a horizontal asymptote? Sometimes you do, sometimes you don't. So that's when we compare the leading term on top. Let's say the leading term is a1 x to the power of m over b1 x to the power of n. When the top has the higher power, the x cubed divided by x squared. Does it make sense? There's no horizontal asymptote. I'm just gonna write HA. No horizontal asymptote. What kind of asymptote? It could be slant asymptote if you end up with a line equation. If you end up with a quadratic, the behavior will behave like a quadratic, and so on and so forth. If they have the same degree, this is both x squared, or x over x, or x cubed over x cubed, then yes, there is a horizontal asymptote. What is it? Horizontal asymptote is y equals to a over b. Just take the leading term and divide, right? Cancel the x. What about when the top has the lower degree and the bottom has the higher degree, like 1 over x after you simplified? That means when you substitute x is a big number, y will also approach to 0. This is the horizontal asymptote. Yeah? Whenever the bottom has the higher degree, you get a horizontal asymptote approaching to 0. So generally, that's what's going on. Some student might ask, Mrs. A, how do you know the curve is above or below? Today we're going to teach you another trick, strategy, called sign diagram. If I know in this interval, is the y value positive or negative, that's very helpful. And I can sketch, okay, the curve is here, or it should be here, right? Okay, let's use this one as an example. First step, factor. Let's take the x minus 1, x minus 2 as the numerator. Denominator, they both have x. Okay. Cancel the common factor. If you are able to cancel something, that will give you the undefined point as a hole on the curve. So where's the hole? Is at x equal to 1. This is supposed to be undefined. If you go to the decimal graph, and you find that point is undefined. But we want you to find the location. So So how do I find the location of that
Wait, why is it
empty
undefined?
points? We will substitute into the simplified. This is the simplified
Wait, Miss A, why is
expression.
it undefined?
Because it will make the, when you substitute 1 into the function, 1 square minus 1 is 0, so that's undefined, right?
Oh wait, so you need to, like, when you find the whole, you can't plug it back into like the simplified equation?
You can only substitute into the simplified because I already canceled that. So it will not become 0. The
Wait,
purpose of
what?
substitute into the simplified version is to find the location of that undefined point.
Yeah, but then, oh,
Yeah,
So
it's
then-
not saying this point is defined. No, it's undefined, but where is it?
Oh,
Where's the
like,
hole?
it's still valid.
It's still
just like, it's not there.
undefined.
Like the point itself is undefined.
Oh.
But we have to find that undefined point.
Yeah, you have
That's
to
when you
find
plug
where
it in.
that is.
Yeah, you're right, you have to plug it in.
So that's why I can only plug it in
In the
after I get rid of that factor, right? Without getting rid of it like this, I will never get the answer.
okay.
So now I can substitute 1 into this part. So 1 minus 2 over 1 is 1 negative 1. See, I can find the whole location. Otherwise, I don't know. X equal to 1 could be anywhere, but the whole is actually here.
Wait, so then what answer would we write? Just like the 1 negative 1, right?
Yeah, 1 negative 1, that's where the hole is. The vertical asymptote is where the denominator equal to 0. So, x equal to 0 is a line equation. Do not just write 0, that's incorrect. And you come here to draw the line. The dashed line, not the solid line, please. Today, a lot of you draw solid line. And you label the asymptote. Horizontal asymptote, take the leading term and divide. I can go to the not simplified one. See that? Leading term. X squared over x squared, that will be 1. Same degree, right? Y equals to 1 is my horizontal asymptote. Go ahead and draw that dashed line. And label. Label the asymptote. Is there a 0 x-intercept?
Yes.
We need to look at where? The numerator, because when y equals to 0, only the numerator allowed to be 0, not the denominator, right? So look at the numerator and find 0. So where is that? X equals to 2. Come here, find x equals to 2. There you go. That's my x-intercept. Is there a y-intercept?
No.
0, substitute that in. Oh, yeah, there is no. X, oh, wait.
So why is there no y-intercept?
Yeah,
Because you can't
Oh,
divide
yeah,
anything
because-
by 0, right?
because x is 0 is the restriction, right? If I write the domain restriction, x cannot be 0 or -1. So x cannot be 0. That's why there is a vertical asymptote, cannot be crossed.
Wait, but I thought in general, like, you can't divide anything by 0.
You cannot.
So it would be undefined anyways.
For this equation, I might have an equation with no 0.
Yeah,
X,
but
no x equal to 0.
No, like if like the vertical and asymptote was like x equals to like 2, what would the y-intercept be?
Yeah, if
Because
I
it'll
have
still be
x
undefined,
minus
right?
1, x minus 2. If this is my function,
Yeah.
then this will be 0. 0 minus 1 is -1. 0 minus 2 is -2.
No, like what if
That's
it's
1
just
half.
no, like what if no, like what if it's just over x?
There's no y-intercept.
Yeah, it'll be nowhere.
No y-intercept, yes, none. Okay, now, based on this graph, you know the vertical asymptote has cut our curve into two pieces, correct? And I have 2 points here. This is supposed to be connected. Based on our knowledge, I should connect this two. And based on how it flows, the behavior near the vertical asymptote should be either go down to negative infinity or go up. So I know it's going to be go down. On the right, you should approach to horizontal asymptote. So you should just hovering under it. Okay? This is a simple 1 degree over 1 degree. When you do this enough, you will know the other piece is actually on this side. Reflect across that, you know, 2 vertical horizontal axes. So it should be here. If I want to find the actual very accurate point, I can substitute x into it. I can say if x is equal to -1, what is y? So -1 minus 2 over -1, that will be what? 3. So -1, 3 will be a point. You see what I mean? -2, that will be -2 minus 2 over -2, that will be 2. So, like that. So, you can do it in that way. All right. What I want to show you is I can create a sign diagram to see is y positive or negative. So I'm going to show you for the next graph, okay? Right here. Oh, let's do another one. Do another practice. When we do factor the top, +5 minus 1, right? Denominator, oops, x plus 4, x plus 5. Are you working on this along with me? Where is the hole?
-5.
-5. Yes, -5. I'm going to substitute -5 into the simplified version. So now, -5 minus 1 over -5 plus 4. So where is the whole? 6. -5, 6. Great. -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And plot it. Vertical asymptote. Denominator. X is equal to -4. Horizontal asymptote. Do they have the same degree? So 1x squared divided by 1x squared, y equals to 1. Let's draw that. Remember to label your asymptote. X equals to -4, y equals to 1. Zeros. Zeros, we're gonna set the top equal to 0. Top of the fraction. So x equals to 1. At that point, going for me. Y-intercept, x equal to 0. When I do y-intercept, I can do it here or there, doesn't matter. Anyway, 0, -1 over 4, right? 0, -1 over 4. So I have 2 points. You see this 2 point has to connect. Let's make it smooth. You know how it's gonna go, right? Horizontal asymptote, so I need to go under it. There is no other x-intercept. I cannot cut the x-axis anymore. Here, if I would have shoot up, I will cross x-axis again, so that couldn't be. I need to go down. See that? Now I have this piece. Where is the other piece? Well, I can substitute 1 point. Say x equals to -6 into that. So y is -6 minus 1, -6 plus 4, 7 over 2, about 3.5. 3.5. Anyway, just give you a general idea. Right here. Oh, look at that. My hole is right there. So my curve will actually pass it. I think the hole is like, it's on the path. You just need to jump over. Okay? So it is still on the curve. So we will connect. There you go. See? Your homework has to satisfy all these criteria. Asymptote, clearly labeled. XY intercept should be labeled. This is 1, so it's clear. The other one should be labeled because, or at least on the side, you show it. The whole location is labeled, okay? So far, our curve is pretty simple, only 2 pieces. Some of the rational function will cut into 3 pieces because you have 2 vertical asymptotes. 2 walls you cannot cross. So 1 piece of curve is gonna cut into 3 pieces. It becomes quite complicated, so we need more information. That's why we introduce the sign diagram. Sign diagram is referring to sign of y value. Is your y value going to be positive? That means above x-axis, or negative y is below x-axis. When we think of sign diagram, we can first think, what kind of point or situation will the curve change its sign? Yeah? So if the output value y are positive or negative, that is a great piece of information for us to graph, right? In order to find these, think about what place on the graph could potentially cause the sign changes. So think of this example right here. F of x is 1 over x. We already know the curve. Because you have the vertical asymptote here, horizontal asymptote here, you see, right side is positive, right? This is positive y value, left side is negative y value. If I want to draw a sign diagram, this will be the divider on the left side of 0. This is the divider. Left side of 0, y is negative. On the right side of 0, y is positive. You see what I'm doing? I'm trying to sketch a sign diagram for the graph. Another example like this. Y equals to x squared minus 1. I'm going to put it down here. This is x squared, right? X squared minus 1 is going to go down by 1. You see, this part is positive. This part is positive y. In between, this is negative. These are negative y value. So where is the boundary point? What are these 2 points?
Your x.
X-intercept, zeros. So if I can find 0 of a curve, find the zeros. And then divide my line, number line into, let's say this is 1 and negative 1. And I can find a point to test when x is from negative infinity to negative 1, it's y is positive. When x is between negative 1 to 1, y is negative. When x is 1 to infinity, all this interval y will be positive. Yeah? So rational function has both. For a rational function, I can find vertical asymptote, where the x value is. And I can find the zeros. All these value of x, I have to plot on the number line and to check each interval. Test, see if it's positive or negative. So according to this value and determine what sign is at any point in that interval, it will give us a sign diagram. Sign diagram of the y value. See, this is the sign diagram right here.
Wait, why is there some negative?
Y is a negative 1, positive
No.
1.
In between the pluses.
This is negative.
Yeah.
Negative y. This is the sign. Positive, negative, positive. This is telling you y is positive here. Y is negative. In between, y is positive. Okay? Good. So, let's try this. This is your first example with true vertical asymptote. Yeah. Go. I'm going to lead you through this, and you will do the next one on your own. Let's factor. X minus 2 is only one factor. X plus 1, x minus 1. Okay, this is the factor form. Is there any zero?
No.
Yes.
What?
0 is
Oh,
the x-intercept.
zeros.
Yeah.
I mean holes.
No hole, no hole. Yes, you're right about that. Zeros, look at the top. What is my 0?
2.
X equal to 2? Yeah. Right here, 2. Holes, no holes. There's no common factor to be canceled. Vertical asymptote?
Negative 1.
Yeah. Denominator. The undefined value still there. These are the vertical asymptote. There is x equals to negative 1, x equals to 1. Once again, asymptote is a line equation, not 1 and negative 1. I'm just going to sketch it right now. Dash line here, labeled. If you can bring a ruler, that will be nice on the assessment. Horizontal asymptote, what do you think? Is 0, 1?
Y equals 0.
Very good. Compare to the leading term, bottom has the higher degree, yes? So all the horizontal asymptote will be y equal to 0. So we can try to divide. X divided by x squared. That's 1 over x. So when x become infinity, this will approach to 0. So y equal to 0 will be the horizontal asymptote. We do have a horizontal asymptote.
But there's
Label it.
a x-intercept.
Y-intercept,
No, like there's an x-intercept on the asymptote.
it is fine. It is okay.
What?
Why?
Yes.
I thought you can't.
It is okay.
What?
Remember, horizontal asymptote has nothing to do with what's happening in the middle.
What?
It has to do with the end behavior. End
Wait, so-
behavior.
I didn't even know that.
Yeah.
Wait, so what about the end behavior?
End behavior is when x is a huge number, y approach to 0. So in the middle, you can cross as many times as you want, but at the end, you will approach to 0. Okay? Where is my y-intercept? Substitute x equal to 0, I get 2. Yeah? Am I right?
Yeah.
0, 2. Put that on. Oh. I'm gonna label this on top because it's in my way. Okay, right now my information is not very useful. I'm kind of lost here. How is my curve gonna go, right? So this is the time to find the sign diagram. Sign diagram here. I can draw a number line right below it. And what I do is I go find two things. Vertical asymptote and 0. These are the value I need to put down on my sign diagram. So, -1, 1, and 2. Are you with me? All the value under vertical asymptote and 0 has to be put down here. So once you put down these values, you have 1, 2, 3, 4 intervals. We need to know if the y value gonna be positive or negative. Okay? So the first interval is from here to here. Negative infinity to -1. Second interval is from -1 to 1. Third interval here from 1 to 2 and 2 to infinity. I need to check all these intervals, right? How do I do that? This is your factor form. If I substitute a value into the equation, so I can put all the factor here. X minus 2, x plus 1, x minus 1. What I'm doing is I'm going to choose a point in this interval. Any point is fine. Negative infinity to -1. Can I just choose x equals to -5? Put that into this factor. -5 minus 2, that's negative. -5 minus 2 is negative, right? I don't need to find the value. -5 plus 1, still negative. -5 minus 1, negative. Negative times negative times negative is negative. This interval is negative. Okay. From -1 to 1, I can choose 0. I already have a point that is positive. I can can just do positive here. But if you want to test, it's fine. 0 minus 2 is negative. 0 plus 1 is positive. 0 minus 1 is negative. So when you multiply, it's going to be positive. Let's choose a point from 1 to 2. How about 1.5? It's okay to be fraction or decimal because we just want to see if the result for each factor are going to be positive or negative, right? 1.5 minus 2, negative. 1.5 plus 1, positive. 1.5 minus 1, still positive. So you have a number of negative. This is going to be negative in this area, okay? Lastly, x equals to, say, 10, 100, whatever. Yeah, it's going to be positive. Okay? These are my sign diagram.
What if there's like 2 negatives and 2 positives? What's the
So
overall?
that's why the graph looks like gonna go from negative to positive to negative to positive.
So like, what if like your chart and then it goes like 2 negatives and 2 positives?
Anyway, I'm just gonna follow this. Can you give me another scenario later? Now I'm about to sketch. Okay, this is the magic gonna happen. This part is negative. Right here is x-axis, so my graph should be below x-axis. Because I know the behavior near the vertical asymptote should be reached to negative infinity or positive, I know in this case it will go down. What about the other side? It's not gonna shoot up because I have a horizontal asymptote there. Okay? The middle section, from negative 1 to 1, it should be all positive y value. And I already have 2 here. These are my walls. I cannot go cross it. So the only way to go is up. Right here, negative 1. 1 to 2 is negative. X-intercept is here. So I need to approach to vertical asymptote. When I get closer, it will shoot down since it's negative. Here is very tricky. It's positive. Is it okay if I do this? Oops. Ah, hello. Is that good? That's not good. Because we are saying I should have a horizontal asymptote. What that tells me is if x gets bigger, y should approach to 0. If I do it like that, it will approach to infinity, so that's not good.
Approach, wait, why approach?
Approach to 0. So this may be above x-axis,
But isn't that still approaching 0 though?
like that?
Yeah.
No, that is, you see that? You are not telling me it's approaching to 0. 0 should be hovering around the line. So you should go a little bit on the positive. Eventually, you want to
Wait, Miss.
flatten.
Say,
Okay.
why is the chart overall value positive?
This positive?
No, the chart. Why is it overall positive when there's 2 negatives?
Because double negative become positive. Negative times positive times negative, right? I have 2 negative become positive. I have 3 negative will
Oh,
be
it's
negative.
not like.
1 negative will be negative. Yeah. When you are multiplying 3 numbers together. Yeah, this is a little tricky, I'm not gonna lie. But remember, if you have a horizontal asymptote, you have to end up to be hovering that line.
Wait, so horizontal asymptote is just like whatever the things
Horizontal asymptote refer to the end behavior, only looking at the two ends, not the middle. So when x is become big or small number, y will become approaching to that set number.
What if there is no horizontal?
No horizontal asymptote, then we can
Do
look at
anything?
what kind, then we won't ask you to graph it. We're not learning that
How about
complicated.
the ones where it's like a specific number?
Like a what?
Never mind.
I'll show you more examples, okay?
So cute.
So you see, it's pretty involved. You have to show me all these and the sign diagram.
Is there a faster way?
Yes.
How do you know how many lines you draw?
How many piece?
Yeah.
Usually, the vertical asymptote is dividing the curve into different sections. So if I have two lines, two vertical asymptote, usually you have 3 pieces. Yeah. 1 vertical asymptote, 2 pieces. Yeah. Good question. These are the previous 2 questions we did. I'm showing you here. See, when you sketch it on your own, you will notice that it goes up a little bit after you pass that, and then come down to approach to 0. Here. Let's start with the easy one. This is very easy, right? X-intercept, none. Because the numerator, there's no x. Can you tell me y-intercept? 0, -2. Perfect. Vertical asymptote? Can I just say 2? X equals to 2. Is there any hole?
No.
No. Horizontal asymptote? Can I just say 0? Yeah, you're all correct. Just have to be the correct format. Y equal to 0. Now we need to draw the sign diagram. Yeah? The sign diagram, we need to pull out vertical asymptote and 0 we don't have. That means the only value we will put down is 2. So we only have 2 intervals to look at, to check. Okay, let me draw this asymptote first. X equals to 2. Now use that, cannot see. Use this color. Vertical asymptote, dash line. Y-intercept, 0, -2. There's no x-intercept. Y equal to 0 is my horizontal asymptote. Okay, we ready? Let's choose this. Let's test the interval, right? Substitute, okay, 0 into it. There's only one simple fraction, so let's just sub in 0. What is it? Negative. If sub into the function to see if the y value is positive or negative. Okay, let's check. X equals to 5. Substitute that in. 4 over 5 minus 2, that's positive, isn't it? I don't need to know the value, I just need to know the sign. That's very helpful, right? Now I can just, this interval is negative, and I have to pass through that point. Isn't it just down to infinity? Approaching horizontal asymptote. The other one has to be positive, so it's not possible to be here. The only place is here. Okay? This is symmetrical, so I think it's going to pass that point. There you go. Sign diagram, all the information. Oh, I forgot to label my horizontal asymptote. Right here. Okay. Do you want to tackle this on your own on the board, or should I do it one more time?
Do it.
Do it one more time. Okay, I can do that. Let's factor this. Numerator cannot be factored. This is just the same. Denominator, what is denominator?
X minus 5, X plus 5.
Good. All right. Go one by one. X-intercept, is there any? We don't know. Let's see. The numerator. Can 2x squared plus 5 equal to 0?
No.
No, when you move the 5 over, x squared cannot be negative. So, none. No x-intercept, okay? That's good. Y-intercept?
Yeah.
Yeah. Substitute x equal to 0. I like to go to the beginning here. It's easier, right? All the term with x is gone. Negative 1 over 5. Vertical asymptote? Look at the denominator, undefined value. X equals to 5, x equal to negative 5. Well, no holes, because we are not canceling any common factor. Horizontal asymptote, guys?
Yeah.
What is it?
Y equals 2.
Take the leading term. Which term is in charge when it comes to a big value of x? Y equals to 2. Take the leading term and divide. Yeah? They have the same degree. Okay. Now, let me just put all this down first. And then we will create the sign diagram, okay? Vertical asymptote at negative 5. And 5. I like this one. A lot of space. So Brian, look, I have 2 vertical asymptote. How many pieces of curve do you think I will have? 3. One here, one here, and one here. Okay? Horizontal asymptote y equals to 2. Okay, I'm ready to plot 0, negative 1/5. This is not the clean point. I'm going to label it. And that's it. That's the only point I have. Okay. Fair enough. I have another strategy is to create a sign diagram, right? Since I don't have the x-intercept, it's none, the only thing I need to put down on the number line is vertical asymptote, those 2 values, negative 5 and 5. Great. 3 interval for me to check. All right? Let's test a point from negative infinity to negative 5. Let's say x equals to negative 10. Let's go big. All right, here I have 2x squared plus 5 over x plus 5, x minus 5, right? On top is always positive because it's square. At the bottom, that's negative, negative. Together is positive. In the middle, x equals to 0. That is positive, positive, negative. So I got negative in the middle. I already have a point. Actually, I don't really need to do this. Do it anyway. X equals to 10. Positive, 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 all positive. All the value, y value, from 5 to infinity will be positive value. Okay. Now let's graph it. What color is good? Let me use this right color of blue. Okay. Since from negative 5 to 5 is negative, and I already have this point here, I can't go up. The only way is to go down. Yeah. From here to here is positive. That means I can only be in this region, right? Although this is positive, if I come here, I will have to come down here. So be brave. Right there. Okay, this is actually hard to see. Let me make it like that. This interval has to be positive, so it will be like that. You feel better about this? Now I want you to show me next question. And do this on the board. So go ahead. 加油